Welcome to a quick Marcialis math moment. We're going to talk about exponents and we're going to get into the product rule. So let's do it. So first, what is an exponential expression? Well, over here we have what looks like b to the n. So we would say that some number raised to the n power, b to the n. This red n is known as the exponent. Okay, and the b here is going to be our base, and b can represent any number. So b is any number. And for introductory purposes, it's going to be a whole number, right? And n for us is going to be, for now, we're going to do non-negative, which means all positive, non-negative integers or whole numbers. Okay, we'll get into some other numbers later on. Okay, so an exponential expression is just repeated multiplication. So this is b, this right here is b times b times b times b times b n many times whatever this number n is. Like we'll have n number of b's multiplied together. So let's see what that looks like in practice. So I have three examples written down here. Example number 1, 2, and 3. These are our simpler examples. So what we're going to do is write this out in expanded form. Expanded form means 2 raised to the 5th power means I have repeated multiplication of 2 times 2 times 2 times 2 times 2 5 times. It's expanded out here. Pencil's not working. So if I were to solve this or simplify it, I have 2 times 2, that's 4. 2 times 2 is 4, and then I bring this 2 down. 4 times 4 times 2 is 16 times 2. 16 times 2 is 32. This equals 2 to the 5th, right? That looks like a 25. There you go. Next, I have two numbers. The bases happen to be 3, and the exponents happen to be the same. Let's see what happens. Let's write this out in expanded form. I have 3 times 3. This multiplication symbol we're going to keep there. Times 3 times 3. Well, there are 4 of these 3's doing multiplication together. 3 times 3 is 9, times 3 times 3 is 9. That's 81. What we have is 3 repeat multiplication. That's 4. You'll notice that it's the same as 3 raised to the 2 plus 2. I added these two numbers together. And it's easy to see that with numbers. Let's see what it looks like with variables. I'm going to expand it out. Times x times x times x. How many x's are there here? 1, 2, 3, 4, 5, 6, 7. So this is really x to the 7, which if you'll notice means x to the 4th plus 3. 4 plus 3 is 7. So when the bases are equal, right? So b to the n times b to the m. Remember, b is just any number. And for our examples, we're using integers. When the bases are equal, we add the exponents. So I have b raised to the n plus m. We have some more examples on the next slide. Here we have a slightly more complicated exponential expression. 2x squared times x squared. If I were to write this whole thing out, I would have 2 times x times x times x times x. So I have 2, there's no other coefficients to multiply, and 4 x's, x to the 4th. Now our next example is a little more complicated, or so it appears. But when in doubt, we can write it out. 2 times x times x times x times y times 3 times x times y times y times y times y. Well, this, when we're doing multiplication, I'm going to multiply these numbers together, and that's going to give me 6. 2 times 3 is 6. Then I'm going to count my number of x's, and that's going to give me 1, 2, 3, 4. So I have x, repeated multiplication 4 times. And I count the other variables. So I have 1y 2, 3, 4, wait, 1, 2, 3, 4, 5 y's. So I have y to the fifth. This is my final solution. This equals 2x cubed y times 3xy to the fourth. Sometimes you'll see it written as 2xy, and then 3xy to the fourth will be inside parentheses. That means there's multiplication happening there. In summary, when the bases are the same, so here I have b to the n times b to the m, we add the exponent values. So here's the b, same base, and then I have n plus m. So I wrote a numerical example here, 4 squared times 4 to the third equals 4, and then my squared, my 2 plus 3 is in the exponent, end up with 4 to the fifth power. If that were a variable, x cubed times x to the fourth, that would equal x raised to the 3 plus 4 power equals x to the seventh. And even if I had multiple numbers and variables in one expression, 2x squared y cubed z times 4x y to the second z to the fifth. By the way, anywhere you don't see a number, you must assume, or excuse me, it is implied there's a 1 there. So this is going to be 8, which is 2 times 4, x to the 1 plus 2, y to the 3 plus 2, z to the 1 plus 5 equals 8x cubed y to the fifth, z to the sixth. It's been another Marcialis Math moment. Thanks for tuning in. I hope this was helpful. Take care.